Okay, so our learning goal today is I can find the slope of a line using the slope formula. So far what you had done is you found the slope of the line by counting on a graph, rise over run. How much does it rise to get to the next point? How much do I have to run to get to the next point? Well, basically we're still really doing the same thing, but now we're just going to use a formula. What if we don't have a graph? So the slope of a line can be determined using any 2 points on a line. It doesn't matter which 2 you choose. So if you have a whole bunch to choose from that belong to the same line, you get to pick whatever 2 you want. Because the slope of a line can be determined using any 2 points in the line because it is a constant rate of change. Throughout that line, the changes in y over the changes in x will remain the same. It will stay wherever part of that line you work with. The rate of change is constant. So nothing's changed. Just like we have rate of change, slope is also change in y over change in x. It's just that now, instead of when you talk about intervals, every interval is going to have the same changes. Or, as we just said, the formula is m equals m being slope, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. X sub 1, y sub 1 really being one of your points. You called your first point. X sub 2, y sub 2 being your other point. You could call it your second point. So we're going to use that formula a lot this year. Okay? So find the slope of a line that contains these 2 points. This is in your SQ3R. Actually, it's 1B. Go see what you got for this one. What did you get for an answer for 1B? What did you get, Trevor?
-3.
-3. Okay, anybody else get -3? No? Okay. You did something? Jennifer? No, you got a different one. Jennifer wants to offer a different answer. Connor, you got to stay and start with us? Okay. 3. Anybody get 3 like Jennifer? She get a +3, not a -3. Okay. Can it be both? Can a line have more than one slope? No. A line has only one slope. So it doesn't matter which one you let be the x sub 1, y sub 1. Typically what you end up doing is you typically let the first one that is in the list be, and the second one is the x sub 2, y sub 2. So let's set up our formula here. M equals, what are we going to start with upstairs? -4. Subtract a -7. So y sub 2, our y sub 2, we decided to let the second point be the 2's, and the sub 1's are going to be this one. So we're going to have -4 take away -7 over what? Order matter here?
Yes.
Yes, what do we got to start with?
6.
We have to start with the 6. We have to start with the x sub 2 and take away the x sub 1. Well, subtracting a negative is really the same as adding the opposite of it. So this could be changed upstairs to add the opposite of -7? 7, because I would prefer you not use your calculator for these easy problems. And 6 take away 5 downstairs is 1. Even though you've done this in your SQ3R, I expect you to be doing it again now. -4 plus 7 is 3 over 1. When the rise over run can simplify to an integer, remember the integers are the whole numbers and their opposites. When the rise over run, the change in y over the change in x can simplify to an integer, we will simplify it. Can this be simplified to an integer? What integer? 3. So we would say our slope is 3. What would this line do? What would its behavior be? If we did graph it, what should we expect this line to do on a graph? Here are behaviors. Let me remind you. It either rises from left to right, it falls from left to right, it's a horizontal line, or it's a vertical line. What is this? This is a rising. So what I want you to do, I just want you to get in this habit right away. I just want you to, even though you're not going to have to graph, I want you to just make a little diagram of, you know what, here's what I would expect this to do on a graph. Its behavior would look like this. You need to make that connection because sometimes you're you should be able to say, you know what, I can see what the behavior is. Does my slope match that? Okay. This next one is not in your SQ3R. It's a little bit different. It might deceive you and you might think it looks like it, but it's not quite. Go ahead and do this one. Decide which one's going to be which point for you. Which one's going to be your first point, which one's going to be your second point. And just to be different, I think I'll do this. And you go ahead and do whatever way you want. Find the slope of the line that has these 2 points. Now again, I might have chosen my points to be, I let the first one be the second one, and the second one be the first one. It's too different, because it should not matter. Anybody get a positive 9 rather than a negative 9? Yeah, because you let the second point be your x sub 2, y sub 2, didn't you? Okay, but do we all get 0 downstairs? Yeah, we should. Okay, so what's the slope of this line? Undefined. Why? You cannot divide by 0. So we stop right here and say, you know what? You can't divide by 0. So this has an undefined slope. Well, if it has an undefined slope, what is the behavior of this line? Up and down, what kind is that called? It's either it's a vertical line, yeah. So it's a vertical line. So we have ourselves here a vertical line. That's the behavior. That's what we should expect. If I gave you a coordinate plane, told you to graph those 2 points, draw a line through them, you should end up with a vertical line. So you had one kind of like this in your notes, but it wasn't these exact 2 coordinate pairs. What happens if you end up with 0 upstairs instead of downstairs? What if it was 0 over 9? Is 0 over 9 undefined also then? That'd be 0 because you can divide into 0. 0 divided by anything other than itself. 0 divided by anything is 0, so you would have a horizontal line then. So you can have a 0 slope, right? But you can't have a undefined slope. Okay, let's go to the back side. So I put in a new page. Okay. When you're given a table, this one's in your SQ3R. Here's what I want you to do though. You look at your SQ3R and see which points. This would be 2D. This is 2D. Okay, so go find the 2D in your SQ3R. Do not use the same 2 points that you used in your SQ3R. Pick a different combination of points. Pick a different combination of points. You should get the same slope. So you decide which 2 points are you going to use. I'll pick my own 2 and in your SQ3R, and again now, with the other combination of points you chose, you should end up with a slope of -3/2. So either your rise or your run, not both, one of them should turn out negative, and then you end up with a fraction that can be simplified, not to a mixed number, simplified as an improper fraction, so I had 6/4, so I simplified When one of them is negative, the rise or the run, you can pull the negative side out front and make the slope negative. So compare, what happened in your SQ3Rs? Did you get the same slope you did now? Here's what it should have happened in your SQ3Rs. You should have gotten a negative 3/2. You should have gotten a negative 3/2 right now. What would the behavior of this line be? What would this line do? If I asked you to graph those 4 points on a coordinate plane and draw a line through them, what would you expect this graph to do? Go down from left to right. This is what it should do. It should be a falling line from left to right. We need to start making that connection right away. Not asking you to graph them, just start making that connection. What would I see on a graph if I did graph this? Would it give me a little bit of a picture? Anybody have any questions so far? Okay, on this next one, I picked 2 different combinations for you to do. This is not in your SQ3R, by the way. So I picked 2 different combinations. I want you to do both of them. So go ahead and work both of those. So you decide what's going to be your first point and your second point. So you either end up with a positive 13 over a positive 2 for the first combination of points, or a negative 13 over a negative 2, depending on which point you started with. The second one, you either end up with a 6.5 over 1, or a negative 6.5 over a negative 1. Okay, are these the same slope? Now, typically when you see slope, you're not going to see it written as a mixed number. You're not going to see it written as a decimal. So can the first one be simplified into, first of all, an integer? Can 13/2 be an integer? No. Can it be simplified as an improper fraction? Is there anything that goes into 13 that also goes into 2? No. So we would say, you know what? Here's the slope of this line, 13/2, 13 over 2. Every time it rises 13, it runs 2. Okay? Well, this is not how we're going to see it in an answer bank. So what is 6.5 over 1? What can we simplify that to first of all? What's anything divided by 1? Itself. So this is really 6.5, isn't it? And 6.5 is what mixed number? 6.5. And 6.5 is what improper fraction? 2 times 6 is 12 plus 1 is 13, and those are halves, so 13 halves. We get the same thing. Okay? So my point being, we're not going to leave it like this. This is not how we want to leave it. We want it to become integer rise over integer run, or just an integer slope. Okay? What would this line do? What would we expect the behavior of this line to be? Going what? Yeah, this one's going up from left to right, isn't it? This one's rising from left to right. Okay. Anybody have questions on that one at all? Okay, the next one was the interesting one this is the one I was kind of really zeroing in on. So you did this one in your SQ3Rs. It's 3, example 3. And we were to find the slope of the line that graph shows, the graph shows the height of a plant over a period of days. Find the slope of the line, then tell what the slope represents. I saw one SQ3R in here that did that correctly. One. describe what that slope was. So first of all, we gotta get the right slope. So some of you want to share what you got for a slope for this one. Trevor, what'd you get? 1/2. Anybody else get 1/2? Okay. I saw some other slopes. What were some of the other ones I saw? I feel like I saw -1/2 somewhere. Maybe it's -1/2. Is it -1/2?
That's right.
Okay. Now, considering, and thank you for owning up to that, Landon, because here's the deal. Considering what we've just been talking about, the behavior of the line should match what we say the slope is. So what's the behavior of this line? What's it doing? It's going up from left to right. It's rising from left to right. Well, if it's rising from left to right, what kind of slope should it have? Positive slope. So first of all, we gotta have a positive slope, don't we? Now we don't know whether it should be a fraction or an integer. We have no idea, but we know it at least should be a positive slope. Okay. Well, let me caution you about something. You might have been also tempted to do this on this graph, because I am. As soon as I see a graph and they show me 2 points, especially if those points have integer x values and integer y values, I just want to use the counting method. I just want to count and get rise over run, and then go from there. Why use the formula? But I caution you. There's you got to be careful about that. You got to be wise. What would happen if we counted in this one? Can somebody count for us how many grid lines you have to go up or down to get from one of those points to the other? How many grid lines? How many grid lines to get from one of them to the other? 1, 2, 3, 4, 5. You gotta go 5, don't you? 5 grid lines. How many grid lines you gotta go over? 2. Okay, so 5 over 2. Well, that would be a slope of 5 halves. Anybody have that? Well, 5 halves. Yeah, okay. No, we gotta be really careful though, because when we're going up 5 grid lines, what are we really going up? 5 centimeters? Are we going up 5 centimeters? What are we going up? Every grid line is how many centimeters? Not 4. Look again. Every grid line is 2 centimeters, isn't it? They mark every 4th one, but every grid line is really 2 centimeters. What's every grid line going over? 10 centimeters. So do they have the same scale? No, I caution you. When they don't have the same scale, you can't use the counting method as reliably unless you do it like this. If I go up 5, I'm not going up 5, but I'm going up 2 at a time. What would that be? 10. If I go over 2, I'm not going over 2, but I'm going over how much? 20. What's 10 over 20? 100. Rise up 10 over 20. So we should get 1/2. So let's be careful. So that was my little caution about if you want to use the counting method, if you want to use the graph, be careful. The scales have to be the same, or you got to put a bit more thought into it. So let's use the ordered pairs that they gave us. What are they? Help me out. Don't make me look at my book. Come on. 30, 10? 50, 20. Okay. Go ahead and use it finding the formula, or do it again, even if you've probably already done this in your SQ3Rs. Let's see what you get this time. Sure enough, I got 1/2. 10 over 20. Maybe you got -10 over -20 because you started with the other point. Okay. So our slope should be 1/2, and right now I'm feeling kind of good about that because the graph is rising from left to right. So we should get a positive slope. Okay, now here's where we did not do well at all in our SQ3Rs. Tell what this slope represents. What is this telling us? What is 1/2 telling us? We're going to be specific. Just like we have to be with the intercepts. When we talked about rate of change, we have to be specific. What can we say here, Trevor?
It averaged 5 rows in centimeters each day.
Okay, well, what is that? Let's be specific. What is it? What's it doing? What is this plant growing? Okay, here's what I do. I give labels to my rise over run. So I say 1/2. That one upstairs is a y value. What are the y's again? Are those centimeters or days? Centimeters. So I say this is 1 centimeter. And that 2 downstairs is an x value. Those are the days. So it's 2 days. So I just like to describe it just like that. I give labels to the up and down, and then I say, you know what this tells me? The plant is growing at a rate of, just like Trevor said, it's a rate. But what can we say? At a rate of what? 1 centimeter every 2 days. 1 centimeter every 2 days. We have to be that specific. Use those numbers. Now there's another way to state that. Anybody think they know another way we could state it? If it's growing 1 centimeter every 2 days, what if you had to write it as a unit rate? Or what if you chose to, Matt? Yeah, it's growing at a rate of 1/2 centimeter every day. So in other words, we can put that 1/2 over 1. We can make the 1/2 into our centimeters and the 1 into our days. And we could say it's growing at a rate of 1/2 centimeter every day. Or we could just leave it like this, growing at a rate of 1 centimeter every 2 days. So you need to shape up your SQ3Rs also. Okay? Anybody have any questions? Okay. Now let's go to work at home.